All right, we are starting chapter 2, moving into rational numbers. So at the beginning, we have just a little bit of fraction practice to kind of refresh your memory here. I'm going to let you do this on your own, but I'm just going to give you a few reminders about fractions. So when we add or subtract fractions, I need a common denominator. Okay, and so what this looks like, so for example, I have 1/8 plus 1/9. I need a common denominator between the two of them. The easiest one that I can think of is just 8 times 9. Okay, so 8 times 9, if I do this times 9, I have to multiply the top times 9. And that's going to give me 9 over 72. I'm going to do the same thing over here, but I'm going to multiply by 8, because it's going to give me the same denominator of 72. And then I've got 8 times 1. Now I can just add across. 8 plus 8 is 16, plus 1 is 17. 17 over 72 is my answer for that one. When I multiply, I can just multiply straight across. I don't have to do anything. But when I divide, I have two options. So if we look at this one, first option is to have a common denominator. So I could have a common denominator of 16. So to get that, I would need to multiply this by 2, right? So then I would have 14 over 16 divided by 11 over 16, which is just going to give me 14 over 11. The other way that I could do this is my keep, change, flip, right? So I keep my first fraction, change my sign, and flip my second fraction. So if I did it that way, it would set up like this. I've got 7/8, keep my first one, change my sign to times, flip my second one, 16 over 11. Now when I do this, I can cross simplify. So, because if I could just multiply across, but then that's a really big number over 88. Instead, I can make this a little simpler. So I can look at this and I can look at, can I simplify here or can I simplify here? Well, I can see that 8 and 16, 8 goes into both of those, right? So I can make this say 1. This would be a 2. So now I just multiply across. 7 times 2 is equal to 14. 11 times 1 is just 11. 14 over 11. I will let you do the rest on your own, so we're just going to go down here to some vocabulary. So, first one is a rational number. So, rational numbers is a number that can be written as a fraction. So, for example, I have down here a little chart of rational numbers, okay? As you can see, there's a bunch of things in this. So rational numbers is just this outside box, right? And all of the numbers inside of it fall under rational numbers. So a rational number can be whole numbers, so 1, 2, 3, 4. It can be integers, which we just talked about in chapter 1. So whole numbers that are positive or negative, or it can be some of these outside things. All of these can be written as fractions, okay? So for example, I've got 4 here. Well, 4 can be written as a fraction, like 4 over 1, right? That's a fraction. -2, same thing, -2 over 1. Okay, 5 and 8/10. 5 and 8 over 10, which I could simplify to 5 and 4/5, right? Rational numbers are numbers that can be written as fractions. So there are certain decimals that will fall under this. And so terminating decimals means that a number with decimals number with decimals that ends. Okay, so for example, or that I can, I have like my 5.8, right? I've got a decimal that ends. This is my terminating decimal. 1 1/4. 1.25. It ends. This is my terminating decimal. So decimal that ends stops the whole thing. Repeating decimal is a decimal that repeats in a pattern. Decimal that repeats in a pattern. So, if we're looking at a prime example of this, is 1/3. Okay, if I put 1 divided by 3 in my calculator, it's going to pull up like this. 0.333. It goes on and on and on forever. Okay, that's a repeating decimal. It happens in a pattern. It could also be like this. 0.1515, on and on and on. When I put a line over the top of things, that tells me that it repeats in that pattern. So for example, my 33, I could put a line over just my 3, and I can say that my 3 repeats all the time. In this example, my 1 and my 5 repeat after one another, so I put my line over my 1 and my 5. If I had an example of like 0.246, my line would go over the 2, 4, and the 6 to let me know that it repeats that over and over again. Okay? All right, we are going to look at ordering these from least to greatest. So I've got -1/2, 1 1/4, -1/3, 1/2, and -5/3. So I need to look at this and see which one is my smallest number. Well, I know it's going to be a negative number, and I need to look at my biggest negative number, which looks to me like this one. So I've got -5/3 first. This is -5/3. Why aren't you working? I've got -5/3. That's a little bit better. Okay. My next one is going to be a -1/2. Next will be my -1/3. Next will be my +1/2. And then my last one is 1 1/4. I want you to do the same thing for number 2 on your own. I'm going to move on for now. We're going to write the rational number as a decimal. Okay, this is pretty simple. So I already see I've got a -4 here, a whole number. But, okay. So I've got -4. And then I'm going to have a decimal point, I know that. -4. Let's try this again. Here we go. I have -4. And then I have 2/3 as a decimal. Now you could just divide 2 divided by 3 in your calculator, but eventually you're just going to learn that 2/3 as a decimal is just 0.6 repeating. So my decimal is going to be -4.66 repeating. I can put a line over the top of it. 66 repeating. You can do the same thing with this one. So I'm going to have one whole, I know that. And then I've got 7 divided by 16, which I'm going to need my calculator for. So I've got 7 divided by 16. It's going to give me 1 and 4, 3, 7, 5. 1.4375. Get rid of this guy right here. Whoop. 4375. All right. Pretty simple, right? Now we're going to move on to making a decimal a fraction, which is a little trickier, but we can do it. So my first one, the way that I read this is not negative 0.84, right? The way I read this is negative 84 hundredths. So the way that I'm going to write that as a fraction is negative 84 hundredths divided by 100. Can I simplify this? Yes, I can. I can look at this and I can think, okay, well, I know that 4 is going to go into both of these. 4 goes into 84 21 times. 4 goes into 100 25 times. Negative 21 over 25. That's in simplest form. I can stop there. Next, I've got 5 and 22 over 100. Can I simplify this? Yes, I can. 2 I know goes into both of those. So I've got 5 and 11 fiftieths. 11 over 50. All right. Last one then. I also know that this is going to be a negative 1. Then I have to do 716 divided by, now this is 1,000. Divided by 1,000. Okay, I might not know. So with my first one, I looked at 84 and 100, and I knew that 84 and 100 had a common factor of 4. I could look at that and it was pretty obvious to me that they had a common factor of 4. Well, it's not as obvious to me here that I have a bigger factor than 2, so I'm just going to start with 2. Right, so I've got negative 1. If I divide both of these by 2, 716 divided by 2 gives me 358. And then 1,000 divided by 2 is 500. Well, I can look at that and see I can divide that by 2 again. So that equals negative 1. 358 divided by 2 is 179. And then 500 divided by 2 is 250. And I think that that's the smallest I can go. So that is my simplest form. Okay, last one here. We've got a word problem. Table shows the position of each runner relative to when the first place finisher crossed the finish line. Who finished in second place? So the way we have to think about this is our first place finisher. Here's my finish line. My first place finisher crossed it, so this is 0. All of my other players all of my other runners that are back here are, I should do this the other way, probably. It'll make more sense. So here's my finish line. This is my 0. All of my other players are back here. My runners are back here. And so they're all going to be less than 0, right? They are behind the finish line. And so when I'm looking at who finished in second place, what I need to really look at is who finished the closest to 0. So I can see this is negative 1.264, okay? That's probably not very close to 0. Negative 5/4 is the same as negative 1 and 1/4, so negative 1.25. Come over here. I've got negative 14 over 25. which is the same as negative 0.56. And then over here I've got negative 13 divided by 8, which is going to give me a negative 1.625. So now if I'm looking at who's in second place, well, I can look at this and say my 0.48 is the closest to 0. So player D came in second. So I'm just going to go in order and see where all of these players came into play, right? So that came in second. Player E came in third, right? That goes next. Fourth, looks like it was player C that came in fourth. Came in fifth place is what I need to look at next. It's going to be player B. Sixth place looks like player A. Seventh place, is player F. So, second place was player D, fifth place, player B. And that is all for 2.1.